Bismillahirrahmanirrahim and Assalamu alaikum. How are you, students? Hope you are doing well. Today we are going to study Dalton's law for partial pressure of the gases. Let's see what does it mean. Dalton's law for partial pressure states that total pressure of the mixture of the gases is equal to the sum of the partial pressure of the each component gas that's present inside the mixture or that system. Okay, let's consider that we have two containers. First container and second container. Each one of them has 1 liter volume. We can say that volume of this is 1 liter. For this one is also 1 liter. The pressure over here is P1, okay, for the gas 1. And the pressure for the next gas is P2. If we add these two gases in a 1 liter volume container, it's same place, the total pressure of them will be P1 is equal to P2. This is the thing the Dalton wants to tell us. P1 and P2 is the partial pressure separately for each gas. Let's study this in a mathematically. Dalton's law of partial pressure can be mathematically expressed as follows. We can say that P total is equal to summation of summation of Pi, in which I is starting from 1, it is not 2, it is 1, I is starting from 1 up to n. If we simplify this, we can also write that P total is equal to P1 plus P2 plus P3 plus up to Pn. If we sum up the partial pressure of the all gases that are present inside the mixture, we will get the total pressure of the gases. Okay, so over here P total is the total pressure of the gases of the mixture, and P1, P2 up to Pn are the partial pressure of the each separate gas that is present inside the mixture. Well, students, we can also express this in other way. We can use mole fraction. You remember the mole fraction, right? We can also write that partial pressure for the gas A is equal to mole fraction of the gas A times partial pressure, total pressure of the mixture. Or in other words, we can also say that mole fraction of the gas A will be equal to partial pressure of the gas A by total pressure of the mixture. Okay, we can use these equations to solve question for the partial pressure as well. And we can also, if you remember that the mole fraction was something like this. Mole fraction for the A was number of moles of A divided by the number of moles of mixture, or the total moles. This was the mole fraction, okay? So please remember this. And the next thing that I'm going to tell you is that we can also use ideal gas law to find the partial pressure for the each gas. We remember from ideal gas law that the ideal gas law was equal to PV is equal to nRT. Right now we are talking about the number of moles and pressure of the gases. So the RT and V over here, the ideal gas constant, temperature and volume are constant here. So only the variables are pressure and number of moles. So we can change the shape something like this. P is equal to nRT by V. We divided V at the both sides of the equation. So if we are going to find out the partial pressure for the gas A, we can put A here. Okay? PA is equal to NA times RT by V. Or if we are going to find out the partial pressure for another gas, like as a sample gas B, we can say something like this. PB is equal to NB times RT by V. These equations, these two equations can also be used for each separate gases to find the partial pressures. But at the end, to sum up the partial pressures, we will sum all the partial pressures to find the total pressure of the mixture of the gas. Okay, let's work upon an example. The example is a mixture contains 6.7 moles of hydrogen gas and 3.3 moles of oxygen gas. This mixture is in 300 liter container, and the temperature is 273 degree Kelvins, and we are going to find the partial pressure for each gases. First of all, let's make an outline of this question. We know that for hydrogen it's 6.7 moles. For hydrogen we have 6.7 moles. And for oxygen, it's 3.3 mole. Oxygen, 3.3 mole. And volume is given. Volume is 300 liter. The temperature is 273 degree Kelvins. And the total pressure is P total is equal to 0.75 atmosphere. What's the question? We are going to find the partial pressure for each gas, for hydrogen and oxygen. So pH2 and PO2 are question mark. So students, let's solve this question. I am going to use the equation which was partial pressure of the gas A is equal to mole fraction A times total pressure, because total pressure is given over here. So that was the easiest way to find the answer of this question. So let's write that partial pressure for hydrogen H2 is equal to mole fraction of hydrogen times total pressure of the mixture. So first of all, we have to find the mole fraction of the hydrogen because we need it for the equation. So if we want to find the mole fraction of the hydrogen, we can write H2 is equal to number of moles of hydrogen divided by the total moles. So what's the number of mole of hydrogen? It is 6.7 mole divided by, what's the total mole of the mixture? 6.7 plus 3.3, 6.7 plus 3.3 mole. So they will make the mole fraction of hydrogen is equal to 6.7 mole. We can cancel mole by mole divided by 10. 6.7 divided by 10 is 0.67. This is the mole fraction of the hydrogen. Now we can put this mole fraction in the equation, and we have the value of P total as well, and we can find the answer, which is the partial pressure for the hydrogen. So partial pressure for the hydrogen is equal to the value of X is 0.76 times the value of total pressure is 0.75 atmosphere. Okay, so the partial pressure of hydrogen gas, if we multiply 0.76 times 0.75, it will become 0.5025 atmosphere. This is the partial pressure for the hydrogen. Now which is remaining? Partial pressure for the oxygen gas. Let's find the partial pressure for the oxygen. Again, we have to find the mole fraction for the oxygen. XO2 is equal to, what's the number of mole of oxygen? It's 3.3 moles divided by 3.3 plus 6.7 mole. So again, 3.3 is in numerator divided by 10. What will be the answer? Partial pressure for, mole fraction for the oxygen is equal to 0.33. Now we have the mole fraction of the oxygen. We can put this value in the equation so we can find the partial pressure for the oxygen. So from the equation of the partial pressure, we remember that PO2 will be equal to XO2 times P total. Yes. So PO2 is equal to, what's XO2 or the mole fraction of the oxygen? It is 0.33 times, what's the P total? It's 0.75 atmosphere. So what will be the partial pressure for the oxygen? PO2, it will be equal to, if you multiply these two, the answer will be 0.2475 atmosphere. So this was the partial pressure for the oxygen. We remember the partial pressure for the hydrogen was 0.5025, and the partial pressure for the oxygen is 0.2475. And from the very beginning, I told you an equation that P total was equal to P1 plus P2. So let's see that if they are equal or not. We can write P total is equal to PO2 plus PH2. What's the value of P total? The value of P total is 0.75. 0.75 is equal to, what's the value for the PO2? It is 0.24. 2475 plus what was the value of the partial pressure of the hydrogen from previous slide? Yes, it is 0.5025. 0.5025. If we add up these two values, it will be equal to 0.75. So 0.75 equal to 0.75, which means that our answer is correct. Well, students, hope you have learned today's lesson. It was not much difficult, and still, if you have any question, you can write in the comment section below. Please don't forget to subscribe our channel and like our videos. Have a nice day. See you next time. Goodbye.